Okay, guys, so we are going to solve this problem together, which involves the uh, absolute inequality. So we have many different ways of actually solving problems like these. And one of the most common technique that is used is the normal definition or the formal definition of the absolute function. And then the other one which comes is the use of the graphs or plots to solve absolute inequalities or equations. But for equations like these, especially which you have this kind of structure, whether it's an equation, whether it's an inequality, which is the structure, is what we're seeing there. There is always a much faster technique for solving such equations. So the first technique, it is based on the following definition. So if you have done the study of absolute function, you have encountered the definition of the square root, which says that the square root of x squared is just the same as the absolute value of x. So it is this result that we usually use when we are solving inequalities of that type, because it brings us back to what we already done in high school, which is the solution of quadratic inequalities. So in order to use this result to solve this equation, it follows that if maybe I have root of x plus a all squared, this is the same thing as just saying the absolute value of x plus a, like that. So for our inequalities, then what happens? So for our inequality, it follows that this can be reinterpreted as just meaning a square root of 1 plus 3x squared is less than square root of 4 minus x squared, where we have used this definition in reverse to express these absolute functions into that. Now we have the square root sign in both sides, so one can square both sides to get rid of this square root, which leaves us with 1 plus 3x all squared is less than 4 minus x all squared, like that. You see, so when now you have this, the next thing that you can do, you can then expand both the left and the right hand side, which in this case will give us 1 plus 6x plus 9x squared is less than 16 minus 8x plus x squared. Now we can take all the material on the right hand side and throw it on the left hand side, and then this will lead us to get x squared will be separated from that, so we'll get 8x squared, and then this will give us plus 14x, then this and that will get minus 15 is less than or equal to 0, like that. So this is what we have. So if you look at where we are sitting right now, this is a normal quadratic equation for which everyone is familiar how to proceed from there. So now this is how we're going to proceed. So we are going to use this familiar technique that if you want to factorize this, you can take the coefficient of the quadratic term and the constant and multiply them together, which will give you negative 120 x squared, like that. Then the next thing that we're going to do, we're going to look for factors, two factors of this number, which are such that when you add them together, they give us the middle term here, which is in this case is 14x. But you can use many other different techniques that you use for factorization. So here it follows that now, if you can think of such two numbers, you will see that the best numbers actually are 20 and 6, because if you say 20 by 6, it will give us negative 120. And then if you take them in the order that 20 is positive and 6 is negative, we'll get at this 14. So it follows from here that we have 8x squared plus 20x minus 6x minus 15 is less than or equal to 0. So now we can factorize using grouping. So we can take this as the first group, and that one is the second group. So the common factor for the second group is just 2x. So if you pull out 2x from here, so it's 4x actually. So yeah, it's 4x. When you pull out 4x, you will get 2x, then you get 5 that side, and here the common factor we see is -3. So when you pull out -3, you get 2x plus 5 is less than 0. So it follows from here that 2x plus 5, 4x minus 3 is less than or equal to 0. So from here we can now get what we call this, our critical values. So what are our critical values now here? So critical values are, so to critical values, I think we still recall from high school that you take each of these factors and you equate them to 0, which will give us that x is equal to -5/2, and the other one will give us that x is equal to 3/4. You see that? So when you have these critical values, we know now that one of the techniques to finish up is to draw a number line and represent these critical values on a number line, which is -5/2 and 3/4, like that. So we know that when you represent these critical values on a number line, they tend to create 3 different regions on this number line. We have this region which lies on the far left, which is the region which represents all values of x which are less than or equal to -5/2. Then we have the in-between region which represents all values of x which are greater or equal to -5/2, but at the same time less than 3/4. Then we have the final region which consists of everything greater than 3/4, like that. So what we have to do now, all these possible regions that we see there, they are possible solutions. So we know the whole story or how it goes from there. So we can choose any number which is bigger than 3/4 this side. And then 3/4, we know it's 0.25 or 0.75. Then you can choose any number which is greater than 0.75. You can take 1, for instance. So when you put 1 in these two factors, you'll see that you will get a positive expression. So which shows us that we have a positive sign here, and then the signs oscillate and we get that. So therefore the solution that we are looking for is simple, x greater or equal to -5/2 and less than or equal to 3/4. So that's it. So yeah, this is how one can go about solving absolute inequalities by making use of that definition, which at times is one of the easiest technique to use. So it's good to practice different techniques and weigh it out for yourself which one is the best for different types of problem, because sometimes this technique may lead you to one of the difficult parts, where there is the other technique and get to the solution quite simple. So that's it. So next video we're going to solve this problem using the graphical technique, and then we're going to see how it works and how we can get also to the same solution by just playing around with graphical manipulations. Otherwise, thank you.